The Climate Action Reserve is the most experienced and trusted offset registry to serve the carbon markets. As more organizations look to combat climate change and support environmental projects with true integrity, they turn to the reserve to foster real solutions and reductions in greenhouse gas emissions. We are excited to kick off the second series of Carbon Connection and feature external partners with insights and expertise in particular climate sectors and topics across the carbon market. I am your host, Lauren Napuk, and thank you for joining us. Hi, welcome to our next episode of Carbon Connection. Today is a special episode as we are speaking with two guests, McKenzie Smith and Danny Gray, on the Reserve's first ever U.S. low carbon cement protocol. McKenzie Smith is our Reserve in-house expert and associate director and has played a pivotal role in spearheading the protocol development process for low carbon cement. Danny Gray is the Executive Vice President of Strategy and Business Ops at EcoMaterial, where he brings more than 40 years of service in the electric utility, engineering, and coal ash management industries. In this role, Danny manages strategic planning for sustainable cement alternatives in North America. Today, I'm excited to be speaking with McKenzie and Danny about the Reserve's low carbon cement protocol and the significance of low carbon cement in realizing emission reduction goals via carbon projects. McKenzie and Danny, thank you for joining us.
It's great to be here. Thank you.
Thanks, Lauren. Excited. Thank you both so much. Now, as I've mentioned, this is a really exciting episode in time because we've just released the low carbon cement protocol through Climate Action Reserve. So I was hoping to kick things off, Danny, by first asking you, what is the climate and carbon impact of cement globally, and why is cement use on the rise?
Of course. Thanks again for allowing us to join you. As most people in the sustainable industry is aware, cement is a huge emissions source. It's one of the more valuable materials to mankind. On a global basis, about 4 billion tons of cement are produced and used. It's one of the basic building blocks in order to manufacture a ready-mix concrete, which is an essential ingredient. It represents, from a carbon emission standpoint, about 7 to 8% of the global CO2 emissions, and it makes it one of the largest industrial emitters among the industrial sector, which, if you look at global emissions, the industrial sector contributes about 21% of global CO2 emissions. Cement being 7 to 8% of that is one of the largest. So it's extremely important to try to have our industry focus on reduction of CO2 emissions, because concrete, it's an essential material for society, and cement is the main ingredient or the main binder in order to make concrete. So it's an essential material, and demand continues to grow.
Thank you so much, Danny. That's really helpful for understanding why cement use is on the rise. It's in so many of the materials and aspects of our society, as you've mentioned, and it also plays this piece of carbon emissions that we need to reduce. So I appreciate you sharing that. And looking at the cement industry as a whole and realizing the impact of cement, what is the industry doing to combat climate change?
Well, the cement industry, what I refer to as the traditional cement industry, is taking actions trying to lower the CO2 footprint of the manufactured cement. Most of the actions of the traditional cement industry are related to, historically, they have done that through reducing clinker factor by adding SCMs, things like fly ash or granulated blast furnace slag, into the cement clinker process or either the finished process. Today, they're adding more lime. In the United States, it's a little bit different industry in that we are a prescriptive cement and concrete market. So in the United States, instead of the SCMs being added at the cement plant, the SCMs are traditionally added at the ready-mix concrete producer. And that's where a lot of the innovation is going on, is at the ready-mix concrete producer level. And companies that are involved in the sustainable cement side, like our company, who are focusing on reducing and improving the quality of the SCM so that they are innovative and can replace more cement. The historical side of the business has been about 15 to 20% replacement of cement with an SCM or an alternative cementitious material. But where the industry can really have an impact is if we can move that replacement factor 50% or higher. And that's really where a lot of the R&D effort is going on in non-cement manufacturing companies who are focused on the ACM or the SCM side of the quotient. And of course, it's important for the cement industry. In the traditional cement industry at the manufacturing level, it's focused on energy reduction because cement manufacturing is energy intensive, but you have to heat to ultra high temperatures, limestone and calcium carbonate products. And when you have to heat that, you have about 40% of the emissions related to traditional cement manufacturing. Portland cement is associated with that heat input, but about 50% of the emissions is related to just the chemical process where calcium carbonate is in turn releases CO2. So it has a high ratio of CO2 emissions per ton of cement manufactured. So there's some energy efficiency work going on, but it's hard to combat the essential chemistry side of it because that's 50% of the CO2 emissions. So a lot of the work that's going on in the non-traditional cement company type settings is around the ACM and how do you substitute at the concrete level higher and higher ratio. That seems to show promise. And of course, it's where protocol that is really a focus, try to drive that innovation, drive that product in order to help reduce it. So,
Thank you so much, Danny. That's really helpful for understanding the lay of the land and background work that the cement industry is doing to combat climate change and looking to innovate and improve cement generally. And among some of these innovations, I would say, as I'm sure you would agree, is low carbon cement, which we're excited to dive into a little bit more today. So, Danny, I'm wondering if you can share what is low carbon cement and how will low carbon cement address climate change?
well, the terminology low carbon cement refers to a pretty broad base, depending upon who you're talking to. This, when you're talking to cement core, what I call traditional cement manufacturers, it means just adding lime to the cement in the process and reducing it any level, even if it's 10 or 15%, which is generally been where the traditional cement industry has operated over the years. And that's where a lot of their effort. If they add carbon capture and sequestration at a cement plant, that allows them to reduce the emissions even further. But when think of low carbon cement, I'm thinking of products that have the capability of reducing the cement clinker in finished concrete by more than 50%. And in that arena, you can truly have an impact. If you think about 4 billion, soon to be by 2030, 5 billion tons of cement manufacture, if we want to reduce overall emissions, then we need to get well above the 15 or 20% replacement of the CO2 emissions in the concrete at the end. Because cement, even though it's only 10 or 15% of the concrete by weight, it represents about 77% of the CO2 emissions in the finished concrete. And though concrete is the second most abundant used resource in the world, right behind water. So it's essential to societal growth. As the population grows around the world, more concrete and more cement dust is needed. So if you think about low carbon cement, where it can really have an impact, it's crucial that we take steps to get the replacement of clinker at 50% or higher. And that's where most of our company innovation, technology, R&D, and the protocol is an essential piece of that because it helps drive that faster. That's where we can have the most impact on CO2 footprint of the concrete and cement.
Thank you, Danny. That's such a great tee up to my next question, which is actually touching base with our own McKenzie Smith and asking you, McKenzie, to tell us a little bit more about the low carbon cement protocol, which was just released by Climate Action Reserve. So, McKenzie, what is the low carbon cement protocol? Why has it been developed? Why cement? Why now?
That's a great question. Thanks for the awesome tee up, Danny. It's been a great protocol to work on. As Danny mentioned, the cement industry has a very significant impact on emissions. So I think that upfront is probably the decision the reserve took to adopt this protocol and work on it. The low carbon cement protocol is focused on the incentivization of alternative, what are known as supplementary or alternative cementitious materials that could be used instead of Portland cement, as Danny explained. And so by incentivizing the production of those and bringing more of those alternative products to market through the protocol, and allowing for Portland cement to be displaced by these alternative products, we are hopeful that that will have a significant impact positively on emission reductions in the US, as that's where the protocol is developed for right now.
Thank you so much, Mackenzie. That's a really fantastic summary and introduction to the low carbon cement protocol, which people can now access. And Danny, now that we have the low carbon cement protocol, I'm wondering if you can share perspectives about how the protocol will be impactful to communities on the ground.
Sure. Well, many of the technology, things like harvesting man-made pozzolans out of landfills and converting those, having processes and technology that allows us to convert that back into usable cement replacements, harvesting out of what we refer to as harvesting out of landfills or impoundments. It has a super impact on communities because number one, it helps us lower the carbon footprint of the concrete ultimately, and by displacing cement in substituting for cement in the concrete, but it also helps reduce the environmental impacts of having ash impoundment in the communities. So you get the double benefit of doing that, and having the protocol is going to be an incentive and help drive that technology in terms of broad distribution. And if we can drive that in broad distribution in the United States, it's going to be extremely helpful around the world because these deposits of pozzolans are there and can be manufactured into cement replacements around the world. So it's great to have that incentive in place in the United States. Things like driving technologies like we're focused on both harvesting as well as natural pozzolans, manufacturing alternative cement replacement with natural pozzolans. That's a technology that we have that's new, and we feel it's going to be impactful because we are able to roll that out on a national basis now. It's having access to the protocol is going to be impactful for all of the communities in the cement industry. One of the things that we all benefit from when we can substitute more ACMs for cement is it helps reduce the total cost of the concrete for the end user. And the end user means highway departments and citizens, taxpayers throughout the United States. So you get the benefit not only of the environmental improvement, reducing CO2 emissions, but you're also helping control the cost of the embedded material, concrete. And because concrete is such an essential element of society, we need to capture that benefit, and the protocol helps drive that technology to support that expansion rollout throughout the West and eventually throughout the world. These technologies, the United States is not the largest producer of cement. Most of the cement is manufactured externally in the United States. So we can demonstrate these innovative technologies in the United States with a little bit of a push from the advantage of the protocol, give this incentive, then the potential impact on a worldwide basis is tremendous. That's what we're focused on within our company.
Thank you so much, Danny. That was really so forward looking as well, being able to explain how this protocol will be impactful to communities here in the United States, but eventually, hopefully, being able to roll out low carbon cement initiatives globally. So that's really exciting. And now, looking at being able to submit projects through the low carbon cement protocol, I'm wondering, Mackenzie, if you might be able to briefly share what some of the key eligibility criteria that project developers and other stakeholders should keep an eye out to be able to implement the protocol.
Yeah, thanks, Lauren. That's a great question. And you said briefly, so I will tell listeners to go and look at the protocol in depth because the work group did spend a lot of time on these difficult issues to get things right on what projects would or wouldn't be eligible under the protocol. But there are a few areas I think that are important to highlight. Additionality is a big one. It's in all of our protocols, of course. We have both the legal requirement test as well as the performance standard test. So as some examples for the cement protocol, we can't incentivize any projects that are legally required or mandated. So across the US, there are some examples, like in North Carolina, where there is a mandate for projects to go and harvest ash and use that potentially for cement products. And so we found that that would be an ineligible project type under that category according to legal requirements. Or another example in California is the California Transportation Department has set mandates for certain percentages of these alternative products in their state developments. And so those are two examples of ineligibility when it pertains to a legal requirement test. The other part of additionality is a performance standard test where we want to incentivize things that aren't business as usual. And so, as Danny mentioned, there are other traditional products that have been used as alternatives, mainly fresh ash coming from coal-fired plants or traditional slag cements. And so we found that those, along with Portland limestone cement and silica fume, were ineligible because they are readily available in the market today and don't need further incentives. And then we have a list of potentially eligible products, but we've left it open because there's hopes that there will be new novel products that will be coming out that we're not aware of today, and we'll update the protocol over time. Another unique area of eligibility for this protocol was we did include a section on industry standards according to ASTM International, requiring that the products that we are incentivizing meet these industry standards for concrete strength, et cetera, so that we are confident that the products coming to market that we're incentivizing have the capabilities to replace more traditional products and meet the same industry standards. But there's a lot more to it, so I'm happy to highlight those areas.
That's fantastic. Thank you so much, McKenzie. And yes, absolutely encourage everybody listening to go look at the low carbon cement protocol, which is now officially released on the Reserve website. And now that we understand some of this eligibility criteria to get projects up and running, McKenzie, what can we expect the typical timeline for a low carbon cement project to be?
Sure. So the protocol defines the project start date as the date in which these products start to be produced or the production commences. But we have built in, similar to a few other protocols we've recently developed, what we're calling a startup period. It's a 9-month period before that project start date where project developers may be beginning to produce these products, but not at scale, either for research and development purposes or to test out new technology and equipment, as Danny mentioned. So those are sort of the rules around the start date. When it comes to the length of the project, the crediting period is up to 10 years. So it's in alignment with our other industrial protocols, expecting that these investments and the productions at scale will go over that time period. And there is an opportunity to renew that project once for another 10 years. So the length of the project for a crediting period can be up to 20 years.
Great. Thank you so much, McKenzie. That's really helpful for people to understand as they enter this new protocol period and be able to start developing projects through Climate Action Reserve. And speaking of developing these projects, I'm wondering, McKenzie, if you can share who is going to use this protocol to develop carbon offset projects and who is going to purchase the credits?
Great question. Another healthy discussion, I think, at a few different work group meetings. And of course, in our public comment period, we heard some comments as it relates to ownership of the credits. As Danny mentioned, and I'll expand on, is there is a whole supply chain here, of course. There's the producers of these alternative materials, there's the Portland cement industry itself. There are then the purchasers, whether that's a concrete ready mix facility, and then their customers thereafter. So there's a lot of players in this space that have a desire to claim these emission rights. And so right now, the ownership of the credits and emission reduction rights is by default the producer of the alternative product, being that supplementary or alternative cementitious material. But there is opportunities in the protocol that if the ownership of those emission reduction rights want to be owned by someone else, you can transfer those rights to someone else in the supply chain. So we're expecting that most of the project developers will be these producers of alternative cement products and that they'll sell their credits probably typically in our offset market. But there is opportunity for those rights, as I mentioned, to be transferred, and maybe the customer of these products wants to make claims downstream. And so there may be those relationships as well that we can expect, which is a unique aspect, I think, of this new protocol and very exciting. for the reserve to be a part of the whole supply chain, if you will.
Absolutely. No, that's such an important note that you've made, Mackenzie. And I really appreciate you walking us through the protocol top to bottom and ensuring that we have this understanding on how to use it. And before we close today, I want to first just thank you both so much for participating in this episode. But also, Danny, I wanted to just allow you to share any final thoughts or comments you might want to leave us with that we might not have covered during this episode.
Sure, sure. Well, we certainly have enjoyed all of and working with McKinsey and the Reserve from the technical side. We recognize that in our industry, it's one piece of the step to lowering global emissions, and it's an important step. And having the protocol now is a key piece of that. The other thing that's important is that we know that the cement industry represents a significant part of industrial emissions, while the fossil industry is headed in the right direction in terms of reducing emissions. We know that the automotive industry is focused on it as we transition the EVs, as an example. We know that here in the United States, we've had a dramatic reduction in coal-fired electricity. So therefore, some of the traditional SCMs that were available have to be replaced, and we are in the process of doing that. And the innovative ACMs is where that's going to happen. And we see a market in the future where, with the help of the protocol, a lot of the new innovative products that we're bringing on the market, we see SCMs and ACMs actually increasing. And at the same time, the impact of those ACMs by replacing a higher percentage of the Portland cement that's in the finished concrete, we get the added thing of having more volumes. Highway departments, taxpayers can benefit because they continue to get access to lower cost concrete or the infrastructure that it takes to drive our economy. And hopefully we'll be able to reduce imports of cement through substitution. And I see the protocol's true benefit in driving that technology to higher replacement ratios and expanding not only impact the U.S. market, but future impacts on the globe. So we're deeply appreciative of having protocol and having that work accomplished.
Thank you so much, Danny. I really appreciate you sharing that, as we are very excited about the innovations that are being brought to market with this protocol being launched. And we thank you for all of your time in supporting the development of the protocol as well. And thank you, Mackenzie, for leading the protocol development process. And I appreciate both of your time today. And thank you so much for joining.
Enjoyed it. Thank you.
Thanks so much, Lauren.